First lesson on quadratic functions and understanding the graphs of quadratics, and now we're going to use them to solve two real-life problems. So the first problem that we're going to look at comes from physics. So it says if a ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is h of t is equal to 80t minus 16t squared. What is the maximum height reached by the ball? Now let's understand what this actually looks like. So if I draw my graph where my independent variable would be time and my dependent variable is height in this case, what's happening here is that the ball is thrown from the start at 0 seconds. So we're going to just assume that it's thrown from the ground. I know that's a little hard to do, but we're going to do that anyway. We're going to throw the ball up into the air. It's going to reach some kind of maximum height, and then it's going to come back down and hit the ground again. All right, so when it reaches the maximum height, you can see that when I compare the time to the height of the ball, that it takes that parabolic shape. So it creates a parabola from our quadratic function, where the height, or the maximum height that it reaches, becomes that vertex point. So that's what I'm actually looking for. I'm looking for what is the maximum height, or the vertex. So I'm going to take that function. Now I'm going to rearrange it so it looks like it's in standard form. I'm going to make that negative 16t squared plus 80t, where a is equal to negative 16, b is equal to 80, and c is equal to 0. Now I'm going to use my formula for the axis of symmetry. So since I'm based off of time instead of x, I'm going to make my axis of symmetry be t equals negative b over 2a, which is negative 80 over 2 times negative 16. And when I work that out, that gives me approximately 2.5 seconds. So that means that my ball is going to travel for 2.5 seconds when it reaches the maximum height. But I still haven't found that height. What I'm going to do is I'm going to take that 2.5 seconds and I'm going to put it back into my height function. So I'm going to replace my t's with 2.5 seconds because that's where I am actually looking for the height. So when I calculate that, I have 2.5 squared times negative 16 plus 80 times 2.5, and that gives me roughly 100 feet. Paying attention to my units here because my units were given as feet per second. So that means it took my ball 2.5 seconds to reach 100 feet before it started to fall back down. Okay, so I took the equation and just found the vertex and applied it to this situation. All right, let's look at our second example. So our second example comes from economics or business. It says a souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50-cent increase in the price, he will sell about 10 fewer mugs. How much should the shop owner charge for each mug in order to maximize the monthly income from their sales? So I'm going to give my variables a meaning. So I'm going to let my x in this problem equal the number of price increases, because it tells us for every increase in price, for every 50-cent increase in price, he will sell about 10 fewer mugs. So we want to figure out what that is going to give us in order to maximize our income. So my function, I'm going to make it I of x so that it represents good variables, and I'm going to make this be the income. So my x is representing the number of price increases, and my function I of x is going to represent income. Now here's how I'm going to calculate my income. So my income has to be based off of whatever I charge for each mug times the number of mugs that I sell. All right, so when I put this in algebraic form, my income in terms of price increases is equal to. So what I want to do is I'm going to start with $6, but I want to add 50 cents, but I'm not sure how many of those I'm going to have to add. So I'm going to make the fee be $6 plus 50 cents for every increase. I'm going to put my X in there, times the number of mugs. Now, the number of mugs that we're going to sell is about 200, but that's going to be deducted by 10 fewer mugs for every month. So I'm going to do 10x there. So I'm setting up my equation. Now, right now it doesn't look like a quadratic equation because I have this idea into two binomials. So what I'm going to do is FOIL that out. So I'll take my firsts, which are 1200, my outsides, which give me negative 60x, my insides, which gives me about half of 200, which is 100x, and my lasts, which are half of negative 10x, and that's going to give me 5x squared, and that should be negative. Erase that. That should be negative 5x squared. So cleaning this up a little bit, I'm going to combine my outers and inners there. So I'm going to end up with a negative 5x squared plus 40x plus 1200. This is going to be my function for my income based off of how many increases we're going to make. Now, what I'm looking for is to maximize. So I'm looking to maximize that income. So I need that vertex again in this function. So my A is my negative 5, my B is 40, and my C is 1200. So my maximum, or my vertex, is going to show up at negative B over 2 times A. So that's going to give me, when I simplify that out, 4. And remember that 4 represents the number of increases. So we're going to have 4 increases. All right, so if I want to figure out what that maximum increase is, I'm going to plug 4 in for my I in my function, or my X into my function. That's going to give me negative 5 times 4 squared plus 40 times 4 plus 1200. And when I calculate that out, that's going to give me $1,280. So there's going to be 4 increases before I start to lose money. So what's going to happen here, just like the last graph, I'm going to start making more money, making more money, making more money, but I'm going to reach a peak where I start to decline from there. So that peak is after 4 increases, I'm going to make a maximum of $1,280. All right, I'm going to give you some practice problems so that you can utilize these ideas and figure out whether you're looking for minimums or maximums, and that all comes from the vertex. All right, if you have any questions, send me an email. I hope you have a great day.